Perfecting a supply chain is a daunting task. There are so many interrelated variables to consider, and they change daily based on shifting customer requirements and market realities. Supply chain experts at DHL made a giant leap forward in optimizing supply chains with our Transport Network Optimizer.
Hello, my name is Jim Monkmeyer, and I'm President of Transportation and our Lead Logistics Provider Solutions for DHL Supply Chain North America. My educational background is primarily in operations research related to transportation, and so I have a lot of respect for technology and the people that develop it. And I'm excited to be speaking to you today about a new product we've recently deployed, the DHL Transportation Network Optimizer. The Transportation Network Optimizer has truly been transformative. And this is the direct result of the solutioning and operating know-how of DHL, the data science leadership of The Ohio State University, and the concepts we've garnered from the participation in the Inform's annual and business analytics meetings. DHL has 590,000 associates in 220 countries, and that includes DHL Supply Chain, the outright market leader in contract logistics, which includes warehousing, transportation, and value-added services such as packaging and e-commerce. Our team in North America alone manages $4 billion of freight spend annually with carriers and forwarders, and operates 1,500 dedicated fleet tractors and straight trucks, in addition to 500 warehouses. With a network of this size and operating supply chains for many of the largest and most complex multinational corporations in the world, we require powerful technology solutions. TNO is an innovative suite of software and methods which allows for the analysis of multiple transportation network optimization strategies quickly and at scale. The tool was developed to fit a fundamental need in our business. Several years ago, I challenged our team to look across our different solutions and dramatically expand the value we were providing to clients during new business pursuits. Supply chain complexity has been driving ever more diverse and complex solutions, and digitalization has brought about new opportunities to address these complexities. Then COVID created shockwaves and new expectations around supply chain resilience and management. DHL Supply Chain has always taken a highly proactive and we believe pioneering stance on deploying new technologies in our operations, and have made digitalization a real strategic priority, investing millions of dollars each year in transportation management innovation in North America. When it comes to new business opportunities, in some cases, we may only have weeks to sift through data and make proposals. So looking at far more value elements and integrated solutions was a daunting task. This challenge required a step change in our approach to network design. We needed to reduce our analysis time from weeks to hours in order to properly evaluate scenarios and go far deeper on areas of value generation. And we needed to be able to handle larger and larger data sets of orders and shipments in doing so. The proposals being submitted at that time were suboptimal. They failed to give clients the confidence in DHL's actual operating abilities and took weeks to assemble despite the limited value that was being put forward. This is how the TNO tool was born. Normally, we would first look to the outside to purchase software off the shelf, but the available tools primarily focus on a single problem. There are network design tools, fleet optimization tools, and freight optimization tools that assume you're working solely with managed carriers. We wanted something that would look at both optimizing fleet, equipment, and managed carriers at the same time, while going deeper into carrier solutions of consolidations, multi-stops, and backhauls. It just didn't exist in the market and still doesn't. With our North American headquarters based in Columbus, Ohio, it has been natural to partner with The Ohio State University for much of our data science work, and that partnership truly brought immense benefits with this project. Through this partnership, we've been able to build a unique software capability which leverages advanced algorithms, such as ant colony optimization, to produce solutions exploring all network possibilities and configurations of owned fleet and purchased transportation. And as a result, we've seen a 15% increase in our growth rate since the tool was rolled out, with our win percentage at near 60% of the opportunities that we chase. But the benefits of the tool go far beyond giving DHL a competitive advantage to winning more business. The tool has brought an additional 50% increase in the typical cost reduction we find with new business, or over $100 million of additional value to our customers and prospects in its first full year. Better utilization of trucks has reduced mileage, and the resulting lower cost of transportation helps keep costs down for the end consumer. Now let's hear from the team that built the tool and those using it today.
Hello, my name is John Cox, Senior Director, Solutions Design for DHL Supply Chain North America. I have responsibility for our transportation and network solutions design teams here. We support the business through supporting new business pursuits. About 2/3 of the activity that we have in the course of a given year is either supporting pre-sale activities or supporting actual qualified business pursuits. We support all of DHL Supply Chain's transportation products, which would include fleet, capacity solutions through our brokerage team, and LLP, which is our lead logistics partner product. The LLP pursuit process is actually probably the most complex solutions we're going to put together, and we are going to win those opportunities when DHL Supply Chain can communicate superior value relative to our competition. And this is typically in the form of driving out costs from our customers' logistics operation, as well as some more qualitative aspects, such as making the supply chain more visible and making it more resilient. And where my team, where solutions design has a role in this process, is we're tasked with determining the total optimization potential within the customer's network, which you're going to have to focus on several different value levers and modeling approaches. These pursuits are very long-lived, typically multi-month cycles, but they're usually broken down into 3 to 4 week sprints, where each stage of that pursuit cycle, you could have updated data sets, you could have updated assumptions, and you're going to have to rework the solution. And so being able to be nimble and being able to evaluate all these potential cost savings within a complex network in these shortened timeframes, you're going to have powerful optimization software and sophisticated modeling approaches in order to do that correctly. Otherwise, you're going to have to simplify the problem and potentially leave things on the table. Where TNO provides the most value to my team is during these LLP pursuit process. TNO aids our solutions development by allowing my engineers to quickly evaluate transportation networks at scale and identify possible cost-saving strategies. This is done using the 4 modules within the TNO software, either using them independently or as a comprehensive solution. My engineers can then deep dive the initial saving strategies further as needed and refine the solution. TNO allows our solutions design team to evaluate the potential solutions that otherwise we would not have had the capacity to do so, as we don't have other optimization software that can replicate specific solutions that TNO can produce. We just simply don't have the time to solve at scale with our other tools. So as a result, our SD team is identifying a higher amount of potential savings earlier in the pursuit process, which gives DHL Supply Chain a leg up on our competition during these bids.
Hi, I'm Jason Gillespie. I'm Senior Director of our Continuous Improvement, Innovations, and Engineering team for DHL Supply Chain's North American Lead Logistics Partner and Managed Transportation Services. I manage a team of supply chain experts, analysts, and engineers, and we provide multiple functions for the business and the customer, of which value creation or engineered savings opportunities is one. In the CI team, we regularly evaluate opportunities in the network. Value creation is critical to not only having a long-lasting strategic relationship with our customers, but often we have contractual obligations to find new savings after the initial launch and any low-hanging fruit has been recovered during the first wave of the implementation of the solution, which is created by John Cox's solution design team. Then, in combination with our excellent control tower operations, our IT solution, and our carrier development teams, we all work together to achieve our customer goals. Without a solid plan and efficient tools, we are already at a disadvantage. Recently, the continuous improvement team would do this more organically, which requires a seasoned professional to intervene within the operation, farm the data and processes of the business for those opportunities, and then conduct a lengthy and often manual study or collaborate across multiple tools and platforms to identify the size of the prize. We have a toolkit of around 30 items that we are constantly needing to evaluate. And doing so can be limited by time, resources, availability of the data, and customer cooperation. Now we have a targeted list of all of our accounts that we are constantly working through, running the TNO modules and flagging the opportunities. We then work with our account teams to prioritize the opportunities and make sure we focus our energy in the right areas. While there are engineering needs outside of TNO, the tool's advanced algorithm rapidly improves the speed and consistency of the key modules it performs. And those opportunities are typically the most cost impactful for our customers, which can drive revenue back to DHL supply chain. For example, for the first time last year, we hired a new intern to a full-time position. Within weeks, she had mastered the tool and was prolific in creating studies. This ease of use and training removed barriers to what would have never been a realistic task for a new engineer. She was able to do over 30 studies in less than a full year, finding over $20 million in achievable savings on existing live networks. We are sharing this success with other junior engineers, increasing this output while scaling efficiencies.
The tool includes 4 modules that can optimize independently or sequentially by origin, ship or delivery date, and equipment size. The tool analyzes your data to create larger, more efficient full truckload shipments. It identifies opportunities to right-size your dedicated fleet and drivers and further reduce empty miles. It consolidates shipments into lower-cost truckload lanes with deconsolidation in the final mile, further reducing empty miles. Finally, the tool identifies any opportunities for a carrier to pick up freight on its return trip. The tool can be applied to large networks with single or multiple distribution centers. We acquire and analyze your shipment history data up to 1 million shipment records and quickly output optimization opportunities. The output includes a flexible transportation strategy that can be implemented and further tuned based on customer preferences. The tool empowers DHL to maximize your transportation utilization, reduce greenhouse gas emissions, while at the same time cutting costs. The Transport Network Optimizer is the result of our continual investment in both people and technology. Only DHL offers the capabilities found in this tool, which is part of the core services available to our customers. Learn more about how this game-changing technology can refine your transportation operations, save you time and money, and create an optimized end-to-end supply chain.
My name is Manjeet Singh. My team was tasked to research and develop the Transportation Network Optimizer, or in short, the TNO. This is internally known as D3TO. We are responsible for its maintenance, enhancement, and evolution. We have already heard from Jim, John, and Jason about the needs of TNO. One of the retired key leaders, Paul Bugenstein, also clarified the requirements and applications of this tool. In essence, the ask was to build a strategic transportation optimization tool which could process large amounts of data in a quick time and provide us with practical results. The basic premise was to take the numerous nuances and tribal knowledge that are at the disposal of a seasoned transportation solution designer and translate those into logical or mathematical formulations using traditional and emerging OR techniques. One big challenge was to construct a creative and technically sound team who has the ability and adaptability to develop such a theoretically complex yet practical tool. I'm truly proud of our team, primarily Yibo Dang, whom you will hear from later on, and Gan Du, who is building on TNO right now. There were many other partial contributors throughout the development phase of TNO. Another key contributor is Informs itself. Our team has attended Informs conferences for many years. These conferences keep us up to date with latest OR developments, and we also present our work during these sessions. At one Informs annual meeting in particular, I learned about the relevance of Ant-Conley metaheuristics for solving large-scale vehicle routing problems. I brought this knowledge back home to my team, and that became a key starting point for much of our work. As we know, metaheuristics do not guarantee optimal solutions and sometimes may not work at all. Combining metaheuristics with rigorous OR methods for complex subproblems has been a key to our success. Inside our metaheuristics, such as Ant-Conley searches, we leverage rigorous solution methods like dynamic programming and MIP solvers for tackling complex subproblems. we would likely not be able to tackle the large-scale real-life problems that we need to solve without the people with strong OR skills and an open mind to benefit from meta-heuristics. The first major component that was built was to automate the bidding process. Thanks to John, his leaders, and solution designers, we were able to work with bidders as partners. The usual resistance that OR and analytics professionals experience was almost completely avoided. To a great extent, we were partners in helping to implement what the solution designers were asking for. The freight optimization module gives helpful information about potential costs to DHL, which is commercially viable, yet low cost for the customer. Delivering this price in hours instead of days is critical for winning the bids that are profitable. After a bid is won, some of the routes have to be outsourced. Solutions from the freight optimization module helps Jason's group with such outsourcing decisions. Fleet optimization was the next module which builds on freight optimization. Through iterative applications of fleet optimization with different parameters, our solution designers can gauge what number of electric and diesel vehicles make sense for a specific contract or a customer. It also gives a direction to our operators on near optimal closed loop routes feasible for the DHL fleet. The picture shows an electric DHL truck. Electric trucks are not some green fantasy, but are actually cost effective and are increasing part of our fleets right now. This is partly how we are avoiding tons of carbon emission each year. The next module is called the pool point optimization that relates to consolidating less than truckload shipments into full truckload deliveries. It also determines the best hub location to consolidate or deconsolidate these deliveries. This module can be used to determine the optimal network configuration for both inbound and outbound networks. Jason's solution team uses this feature to determine dynamic hub locations for a network within a specified time period. Freight optimization solution can leave long trips with empty backhauls. There is no solution available in the market for finding near optimal round trips. The round trip module bridges this gap and provides solutions which are key to our success. The amount of fuel involved and the waste could be significant. But at this stage of analysis, we are left with fewer vehicles and routes, therefore we used mathematical programming to generate globally optimal round trips, which got us maximum savings. I have provided a high-level overview of software tools within TNO. In summary, TNO provides multiple functionalities within a single platform which are not available in any off-the-shelf software. It processes large amount of data in a relatively short time to generate near optimal solutions. One person who has been a key ally is Ted Allen of the Ohio State University, who was also the former advisor of Yibo Dang. I will turn over the presentation to Ted and then to Yibo to shed further light on technical details of each of our 4 modules.
Thank you, Manjeet. As Manjeet said, my name is Ted Allen from the Ohio State University Integrated Systems Engineering. The Ohio State University has a long history of helping businesses to achieve meaningful outcomes. I became involved because Manjeet called me and asked, do you have anyone who can work on this project? And the one I suggested, Yibo Dang, who will speak after me, became the lead programmer. Yibo and I had just completed a sponsored project for another company that was highly successful, and we were looking for a project that would animate and motivate his primary dissertation topic. The challenge that Jim, John, and Jason laid out is immense. We needed to supply techniques that would operate at an amazingly large scale and bring and codify the powerful expertise of their workforce, who had been developing solutions for a long time. Each of the 4 modules is an integer program, and as Manjeet said, we used a variety of techniques to solve those integer programs. These include dynamic programming and branch and cut. The one that we're going to talk about the most relates to the ability to solve the largest problems in the first 2 modules. It was our red, black, ant colony search involving dynamic programming for subproblems. The 4 modules are used and span effectively both planning for jobs at the bidding time, as well as improving the solutions during prosecuting the supply chains in Jason's group. Generally, we're moving items between stores or warehouses such that there's no last mile to an individual customer. The modules can be used together sequentially or individually. If you use them sequentially, you can think of them as relaxing the sub-solutions. The first two modules essentially solve extremely large problems approximately with the assumption that all the vehicles return to the depot. In freight optimization and in fleet optimization, there are two types of trucks. An essential insight that I helped contribute was the importance of solving all the objectives we can simultaneously to achieve better solutions. In the first case of freight optimization, those were DHL and third-party trucks. In the second case, those could be electric vehicles or diesel trucks. Moving on to the third module, we allowed for the possibility that resources could be positioned and then picked up by the third party so that the third party didn't need to visit the depot. And the final method relates to pruning off or studying the longest trips that are planned to meet the needs. Those trips can be paired, and we can imagine vehicles essentially visiting multiple depots. And for that, because most of the other trips are not important, we could solve with branch and cut. The master problem, as I mentioned, is essentially the same for all modules. We solve it with cherry-picked data and sometimes real customer data. The costs considered include purchasing vehicles, fuel of operations, paying for stayovers, and outsourcing the difficult routes. All the usual constraints in vehicle routing problems apply, including addressing regulations and to protecting the drivers. The main challenge is the extreme scale. Operating hundreds of trucks for weeks means thousands of, or even hundreds of thousands of deliveries. Outsourcing some of the deliveries is absolutely key because of the finiteness of the fleet and the need for profitability. As Manjeet pointed out, the long trips and empty backhauls represent significant waste. Addressing all these challenges is absolutely critical. It might seem that a new type of ant colony search is a little bit far out, but we believe that all of the steps that we've taken are necessary together, and combining these with some hardcore, rigorous methods has been absolutely key to addressing the scale issue. To hammer home the picture of the scale, consider a hypothetical milk run truck of deliveries for an individual truck driver. The driver would need to hit potentially multiple sets of time windows and then return to the depot. Now imagine 100 deliveries, possibly spanning multiple depots. Now we're talking 12 hours to solve to optimality typically, and sometimes more than 20. Now imagine the scale we need to support John's activity and the scale that his solution designers were already hitting before we got involved with their spreadsheet and other methods. They were taking days in many cases to answer. We're seeking to generate useful solutions in less than an hour. This animation shows a large solution with DHL and third-party trucks. Zoom into a single depot. Our ant or truck takes steps probabilistically. The meta-heuristic builds over iterations with paths influenced by droppings from previous iterations called pheromones, which influence the paths and package assignments. The initial and key step is messy, but it defines the contents of each route. The routes are then cleaned up using permutation based on dynamic programming. Dynamic programming straightens the paths and supports the removal of trucks from the plan. The straightening is done in two steps called permutation and mutation. A separate step then assigns the straightened routes to third-party carriers, which we label with red ants or red trucks or ants.
Combining the routes and reducing the fleet size leads to a key source of savings. The two colonies then evolve in symbiosis. The messy routes are constantly being cleaned in each iteration. After the initial freight optimization module is applied, fleet optimization focuses on the same process with the two types of ants being DHL diesel and DHL electric. The outsourced routes and packages are not considered in this step. The resulting system permits DHL solution designers to operate at a scale and with quality that apparently no competitors can match.
I next turn over to the lead programmer and my friend Yibo Dang. He was absolutely critical for all the inventions and took the rough ideas that I had and made them a reality with his impressive creativity and hard work.
Thanks, Ted. As Ted mentioned, I was a lead programmer for the TNO project. Our team had initially developed a relative traditional ant colony search with a second stage assignment for outsourcing, as Ted just mentioned. This method was implemented and used as part of the TNO in its first prototype. Then, we pushed further for additional savings. The red-black ant colony method that we developed starts with the Euro ant colony iteration, having normal routing and dropping the pheromones to enrich future iterations. A key innovation that appears to be needed was to integrate procedures associated with rigorous mathematical methods and solution improvement into this materialistic. My idea was to locally improve the search so that assignments to colors would have a good chance of being relevant. Some of the delivery orders within a single ant pass can be improved through two dynamic programming-based methods. We call them permutation and mutations. These two methods help red-black ant colony escape from trapping into the local minima, and ants can trade deliveries to further clean up their routes. Also, ants with few deliveries can be dropped such that their deliveries can be picked up by nearby ants. Finally, cost-effective ants can switch colors from being outsourced to DHL operated. The algorithm proceeds to run two separate ant colonies followed by further cleanup operations and reassignments. The pheromones for each type of ant influence its own colony only. The core of red-black ant colony search is the red and black transition formulas and their corresponding updating rules. Lastly, we designed a simple machine learning framework to do the fleet size optimization. This idea helps lock in the heterogeneous fleet sizes for group of deliveries, which support additional route refinements and efficiency. We did extensive testing to verify solution quality. By running on small instances, we could compare with Groupie and sometimes exceed the quality. For small instances, our method can deliver solutions within minutes that are generally nearly optimal. The cases in which the solutions were better than Groupie occurred, of course, because Groupie failed to converge within 20 hours. This situation provides some confidence. The derived solutions at the relevant scale of hundreds of thousands of deliveries have good quality. Mathematical solvers may not always be good benchmarks because we know it's not tailored for large-scale problems. Therefore, we picked two well-known counterparts and set the same iteration numbers and repeatedly run every algorithm 5 times. Our red-black ant colony search always outperforms its competitors. While it sacrifices the runtime slightly because of more sophisticated mathematical programming local improvement, we are happy to see that the network cost being cut further and better DHL routes are identified. So, to actually solve the problem for real business size, we rely on red, black, and colony search. As proud of the red, black, and colony search as we are, the extended solutions offer additional opportunities for savings. A key example is what we call pull point optimization. We noticed that the third-party deliveries could cost less if we group the individual packages by a full truckload to a pull point, and then split the final deliveries from the local hubs. For optimizing the pull point locations and package selections, we use an innovative combination of a genetic algorithm and a dynamic programming. This is not shown here, but is explained in our IGA paper. The method that we designed has 3 main steps. The animation shows the basic pull point method stages, and these are provided to John's and Jason's teams to support bidding and operations respectively. Another key challenge relates to long-haul trips and empty backhauls. These trips can span delivery zones, and filling the relevant trucks can generate significant savings. The key question here to be answered is how to arrange the long-haul trucks efficiently so that the trucks can perform the pickup tasks after the scheduled drop-offs. We identify the opportunities using mathematical programming. Let's take a look at an example here. Suppose you have a scheduled delivery from Dallas to Chicago. Once you finish the drop-off, moving an empty truck back can be really costly. However, if there is a software that tells me, hey, you can move your empty truck to Lafayette Facility Center and then pick up cargoes to Fairfield, then a round trip is formed, and my operational costs can be cut almost half. Such paired long trips are identified in our solutions. Then we iteratively cluster shipments and then solve routes optimally for given clusters with mathematical programming. For audience who are interested in more technical details and validation process, we would recommend our patent doc online, which can be referred by the published number at the bottom of the screen. I will now turn the presentation back to Jason, who will talk more about our next steps.
Our operational continuous improvement team has been using TNO for about 1 year, and we've already seen great success. But we've also had some lessons learned. We noticed that the tool was actually identifying savings and value faster than we could implement. So we're working on a better process to make sure we focus more on achievable savings. For example, a network pooling solution is where we can find a better cost option, usually over less than truckload shipments. Also known as LTL, this is where a shipper can send their freight into an existing carrier network for delivery. It is a system of hubs and spokes and can increase touches to the freight, resulting in possible claims for lost or damaged cargo. A pooling solution gives you a cost-competitive alternative to less than truckload with service improvements if there is enough density and freight volumes between certain points. It reduces touches, hubs, and cost when done correctly. To do this solution, you need customer alignment and cooperation, especially if they hold the carrier-vendor contracts, and you need to procure new rates. This can take time and energy across multiple departments, and market rates can fluctuate wildly while you do this due diligence. If not done quickly, the opportunity may shift or disappear. TNO allows us to rapidly identify these scenarios, then we need all hands on deck to hit the milestones in getting the solution in place. We are projecting that with time and scaling, we will take our initial $20 million in savings for our customers and grow that to about $100 million. This is projected by looking at customers we support and their spend and assumes a 3-year timeline with some organic business growth. T&O is a big hit with our customers as well. They appreciate the level of accuracy and proactiveness we have with the tool now, and also they see DHL scientifically solving their supply chain challenges with a variety of best-in-class technologies. I personally never want to be in a position to have a customer ask me why I haven't looked into an opportunity, and since deploying this tool, we really stay ahead of that curve. T&O gives me the confidence to tell our customers that we can reliably, rapidly, and continuously improve their network.
Hi, I'm Sally Miller, and I'm the CIO of North America for DHL Supply Chain and the Digital Transformation Officer. I am proud to represent our ongoing digital transformation initiatives. Our core business at DHL Supply Chain is to operate supply chains on behalf of our customers. Digital leadership and the associated nimbleness in planning and control is critical to our success and growth. T&O has the right assumptions that our solutions designers use. Our designers have used it to save customers tens of millions of dollars and eliminate over 100,000 tons of CO2. No other player in the contract logistics market can solve these problems with the same results and as fast as we can with T&O. I see T&O as truly transformational and critical to our goal of being carbon neutral by 2050 and cutting our emissions in half by 2030. I will turn things over to my colleague, Jim, whose team leads the T&O transformation. Thank you.
So you've now seen some of the benefits T&O has brought to our clients, along with some specifics on how it works. While we continue to expand its use in North America, we also will be exporting it around the world. We use many of the same transportation tools and processes on 6 continents, and the only unique requirement to use the tool in another country or region is the appropriate carrier rate structures. I'd like to close by speaking briefly to the impact DHL and this tool can have around the world with a few brief examples. Our company's global purpose is connecting people, improving lives. And this has really been brought to life in recent years with our global support of vaccine delivery. We have delivered over 2 billion vaccines so far around the world. Here in the US, my team was actively involved in coordinating all vaccine deliveries for one of the primary manufacturers in North America. Another focus area has been disaster relief. Our disaster response team has partnered with the United Nations since 2005. It sends volunteers to manage the flow of humanitarian goods that is arriving at airports in countries that have been hit by natural disasters, such as the recent earthquake in Turkey. We are often the first people on the ground in these situations, relieving bottlenecks in facilities that don't have the infrastructure or equipment to cope with the sudden surge in cargo. These are examples of how we apply our logistics and supply chain expertise and technology to support needs beyond ourselves. I mention them here because they are connected to our investments in technology. The benefits and value we are able to generate through these technologies will benefit our customers, our sustainability partners, and the communities we serve. The Transportation Network Optimizer has proven its ability to deliver value through optimization of supply chain operations. The world has been calling out for supply chains to step up and help address some of the most challenging issues we face today and to deliver even more value to the communities we serve around the world. At DHL, we like to say that we are an essential part of everyday life. Now we can say that the Transportation Network Optimizer is an essential part of everyday life as well. Thank you.